Couple things to remind yourselves of when you're doing, bless you. When you're doing these things, what you're looking for is to get them into your generic form of your equations. You want to get them into your y equals a sine b of x. And all I'm going to do here is just add in a plus k. Now, we're not going to have any horizontal shift to these. Because remember, a cosine graph is just a sine graph shifted to the right pi over 2. Or left pi over 2. And a sine graph is a cosine graph shifted pi over 2. So I'm not going to shift anything for you guys left or right. So you're going to have to be able to identify whether or not it's going to be sine or cosine just by looking at it when it's crossing the y-axis. Remember, a cosine or a sine graph starts somewhere and it either goes up and then down, or it goes down and then up. And then isn't this RNA? I was making stuff up.
Oh, that's a giant accident.
And then you have your cosine values start at a maximum, or they start at a minimum. Well, that was awful.
Wait, if it's a sine graph, is your a value still like how far down?
Yeah, there's still shifting, still vertical stuff here, but it's still, well, another really dead giveaway of knowing whether it's sine or cosine, when you have a sine graph, even if it's shifted up, it's going to cross these 3 points, well, it'll touch the same 3 y values if it's a sine graph. Whereas if it's a cosine graph, even if it's shifted, if it's a cosine graph that's shifted, it's only going to have the same y value twice. That's kind of the dead giveaway of whether or not it's sine or cosine. Sine will have 3 of the same y values. Cosine has 2. Yes, ma'am. When it's to continue on like this?
Yes.
I'm trying to remember. I think there are arrows.
Wait. How's that a sine? How's that a sine graph?
Sine graphs,
No, like it's starting at.
it's just shifted up. Yes.
Okay, I'm confused when you write the equation, when there's pi in it and when there's not.
Okay.
Like, how do you know if there's going to be pi?
When you're worried about with pi or no pi, is after you figure out what your b, that's how you figure out your b value.
Yeah.
So let's go and start with 13. If I start with 13, notice where it starts. It starts at a minimum and proceeds to go to its maximum. That tells you it's what kind of a graph.
It's a negative.
It's a negative and it's a
Cosine.
cosine. It has to be a cosine because it starts at its minimum and it automatically goes to its maximum. Whereas a sine graph would start in between the two. Okay. So here we know this has to be a cosine value. It also has an a value that's going to be negative because it starts at the minimum. Now, what I want you to see is that the maximum and the minimum value are all equidistant to the line y equals 0. You okay with that? So therefore, is there any vertical shift? No. What's your a value then? Maybe negative 4. Okay. Now I'm looking at the horizontal distance between the maximum and the minimum. The horizontal distance between the maximum and the minimum is 1. I double that to get the period. So the period here is 2. Yes, sir.
Will they always give you half the period, or is?
That's the trick. Half the period always occurs between the maximum and the minimum for sine or cosine. Yes, ma'am.
So when we're like doing graphing and like figuring out the stuff, whenever you know whether it's supposed to be that one or if it's just with the K and not with the H, if it's,
There's no H's, don't worry. There's no
I know,
H's.
no, I mean like I'm
Oh.
talking about something else, but you know that it's like that kind of equation
Uh-huh.
when it's only one part of it.
Right.
But when it's continuous, then it's just with the K.
It can be either. We've done graphs where it was just, you know, a small chunk,
Yeah.
a small part. Well, this is just more of it put together to try to throw you off. That's it. You're still looking at a maximum and minimum, and that distance between the maximum and min is still half your time, or half your period. That's all it is. All right? That's all it is. Mike,
So what is the B value do again?
what is it, what?
What does the B value do?
The B value, remember, the period is equal to 2 pi over B. We know that here that our period has to be 2. So I set 2 equal to 2 pi over B, because then I can put that into my y equals a cosine B of x, and we have a plus k thrown out there. It's just how I fill in the blanks for the equation. What does B have to equal? Good. No, it's going to equal pi.
Oh,
So B is going to equal pi. Because what's 2 pi divided by pi? So now you have your B, you have your A, and we figured out that there's no K component because the A value going up 4, the A value going down 4, it's equidistant to the line y equals 0, and you're done. Yes, ma'am?
So, for like when you're in the equation, like when you're asking for when you use pi or not, if your period, like if the lines going up and down are full numbers, not like having to do pi, then you're always going to pi.
Yeah, usually. Yeah.
I was asking
When you
for
whisper,
my-
you talk like this.
I was asking for my paperbacks.
Okay. 14?
Yeah, can we do that one? Because I
That one have
didn't draw the graph well, I just kind of like squiggled on the side.
For the 17th time, will we have any horizontal shift? No, but can we have vertical shift? There's no horizontal shifts here, guys. Once again, everybody listen and pay attention. There's no H in any of these, okay?
That makes it so much
Except when
easier.
there- except when there is a-
You're starting here, you go up, and then you go down. So if you're starting on an intercept, go to a max, then your next spot goes to a minimum, what are you? It's a sine. It's a sine graph. Now I want you to see here is that if I move from here up and then down, the vertical distance between the maximum and the minimum is 2, which means the halfway point has to be 1. So our line here, notice that it touches 1, 2, 3. For one full cycle, it touches it 3 times. It also shows that it's a sine graph. This means that this whole thing's been shifted up 1. Been shifted up 1 from the axis of 0. So there is a k component here. K equals 1. If I'm looking at that k value, what's the distance from the origin, if you will, that k value of 1 to the maximum? 1. So what's your a value? 1. To get your b value, we have to figure out our period. Well, our distance between 1/4 and 3/4 is how much? It's a half. So our period is going to equal 2 times a half, which is 1. I set that equal to 1 equals 2 pi over b. What is b? 2 pi. B in this case would equal 2 pi. So now I have enough information to fill in the blanks. I know that it's y equals, I'm going to put my k value out in front. 1 plus, our a value was 1 sine of 2 pi x.
But you don't get to put that one side, so.
No, you don't have to put 1 in front of the sign, you can just write the sign. Okay. So it's being able to identify that. The other thing that you can tell if there's going to be a vertical component to it is notice your y values. Your y values aren't the same numbers with the absolute value. That means they've moved. Whereas the one prior to it, we had a 4 and a -4. They both have absolute values of 4. That means that they're symmetrical about the line y equals 0. There's no k shift involved. All right. Is it declouding a little? And then lastly, in 15, notice in 15 that right away those ordered pairs they give you, the y values don't have the same absolute value. Do you agree? What would the equation of the line, of the horizontal line be for them to be equidistant to each other?
Minus 2.
Minus 4. If I drew a line through here at y equals -4, that means that there's a k value of -4. We okay with that?
Yeah.
I'm just looking at the graph to identify that they're, now I know that they're equidistant from one another. Well, how far apart is -2 from -4? 2. Did it go up or down? Did it start at a maximum or start at a minimum? So is your a value positive or negative? Positive.
Yeah, can you say?
Oh, yeah.
All right. And when you're looking at this, does this graph start at a maximum or a minimum? Maximum. We know it starts at a maximum. So, we should ask this: is that a cosine or a sine? It's cosine. So we know it's a cosine. It starts at its maximum. So if it starts at a maximum, moves to its minimum, that means your a value is positive. Your a value is positive. How far is it from this line? Well, it's 2. So a is 2. Okay? A is 2. How far apart horizontally is 0 and 2? 2. They're horizontally apart by a distance of 2. I double it to get my period, which is, so if my period, equals 4, I set that equal to 2 pi over b. So what is b?
Pi over 2.
Very good. So b is pi over 2. Now, you guys are looking at me like I'm a little bit crazy to have an a value that's 2, but yet it goes negative. Think about your k shift. Your k shift brings that down 4. So if you started your parent function, you would not start at the shift part, correct? If your a value was 2, you'd start at 2, go through your cycle of moving everything around. Well, if this had a k component of -4, I would take this and move it down to -2. Yes, sir?
Wait, so is that already shifted, or is it shifted from where it's at?
It's already shifted.
Oh, okay.
All these graphs, also, these are all shifted graphs. You just don't see the parent function.
Oh, okay.
All right? So now we have an a value of 2, a b value of pi over 2, and a k value of -4. So I'm going to write it as y equals -4 plus 2 cosine of pi over 2 x. Sometimes it's a little bit easier to put the k out front, especially if it's negative. Okay.
Can you explain the final period of
Sure. Period of sine graph. Let's see, what did we have there?
Number 12 is sine.
12 is sine? Okay. Whether it's a sine graph or a cosine graph, what you always do to figure out the period is find the horizontal distance between the maximum and the minimum. So we want to figure out how far apart is 1/6 from 1/2. pi over 6, and pi over 2. So I'm going to change pi over 2 into 3 pi over 6. 3 pi over 6 minus pi over 6 is? Very good. So the distance between those two is pi over 3, and then I double it to get the period. Because
There's
the,
a little bit, like, I think you divided it in half or something. For number 14, you got 2 divided.
It was times and a half.
it was times, I think it was times,
Like for
2
this
times,
specific
I think
graph.
2 times a half. I think that's why.
Okay.
So in this one here, your period would have been 2 pi over 3. You set that equal to the 2 pi over b to figure out that your b value is 3. Okay? Now you can correct me. Yeah. Sir?
Sorry, I couldn't follow it on 15 like the period.
Oh, sure. Which one was 15? That was this one, right?
Yeah.
Okay. On 15, we saw that we had the horizontal distance between the maximum and the minimum was 2. I immediately double that distance to equal 4. If the period is equal to 4, what I do is I set that equal to 2 pi over b.
Okay, I just multiplied it by 2. I multiplied it by 2 by 2.
Ah, there you go. So when you get to this equation here, you just exchange them on the diagonal. So b is going to equal 2 pi over 4. That's where we got pi over 2. Okay. No problem. Yeah, Michael. The negative 4 is k? All right. What I want you to notice is that you have the maximum and minimum. Your y value is your maximum in the ordered pairs, and it's at negative 2. The minimum has an ordered pair y value of negative 6. Basically, what I'm doing is finding the average between the two. What's negative 2 plus negative 6? What's happening? It's the midpoint. Negative 4 is the midpoint of negative 2 and negative 6. That means that these points are going to be equidistant between here and here. They're both 2 apart. That's what I'm doing. But I visually looked at it and said, hey, between negative 2 and negative 6, if I put negative 4 in between them, there's 2 as a distance between each one of them. Okay? And the reason I said that A was positive here is because the first point is a maximum, the second point is minimum. Yeah.
So basically, it was like, it's like the paragraph would be like, the maximum would be at 2.
Yeah.
And it's shifted down 4.
Yes.
Down to that. Okay.
Could you show 14 again, just so I can see the K value?
14 had a K value of 1 because if you look at it, when we had our 2 ordered pairs, our y coordinates of 2 and 0, what's the halfway point of 2 and 0? 1. So your K value is basically going to be the midpoint of your y's.
And then you said one that wouldn't have that would be like absolute value of negative 4 and 4.
Yes, because what's negative 4 plus 4? Yeah. And that's why that works. That's why that works. Okay? I think I did like all of them, so it's kind of silly of me to take this from you. Let's do this just a little bit differently with what I have for today. And it's actually pretty simple. Izzy, don't worry.
Oh, we're learning.
This is one last little bit of this. Oh, that I ran out of. I didn't have it, but I did. Where was it? Where was it?
I wrote my husband too.
Ah, let's put it in here.
I like.
This is actually pretty easy.
I want to say this about something like arrogant or too shy.
Oh, they really like her.
Yeah, I
If you're bad at writing and thinking about yourself, it's just awful.
Just get rid of the other two.
Oh, the
So we're going to do this just ever so slightly different than what you did yesterday. And this is actually pretty simple. It matches out to be the same stuff from yesterday, minus what?
You just don't get a graph.
You just don't get a graph.
Again, you should have had.
So if I'm looking at this, I'm going to write a function for the sinusoid that has a maximum at A and a minimum at B. They're telling you your max is A and your minimum is B. So what I'm going to do is do a rough sketch of that. And I'm going to create my own curve to see what's going on. So if I have a maximum at 0, 3, 0, 3. Right away, what graph is it? It's a cosine graph. And why is it a cosine graph?
It starts on the.
It starts at x, we know it's a cosine graph, and we also know one other thing we can say right away also.
The minimum.
Well, no, we know that your A value is going to be positive or negative. It's got to be positive. Your A value's got to be positive. Okay. Our second point is at 2, our minimum is at 2 pi and negative 3. So it's doing this.
Wait, how do you know what a 2 pi?
Who cares? I don't mean to say it like that, Izzy, but that's kind of what it is. It's just throw it out there. Because remember, a cosine graph starts at a maximum, goes to its minimum, or starts at its minimum, goes to its maximum. All we have left to do now is find out our horizontal distance here, our period. Remember, half the period occurs in the horizontal distance between your maximum and minimum. Very good, very good. Your horizontal distance here is 2 pi. You double it, you get 4 pi. Set that equal to 2 pi over b, and what's b? Half.
Half.
Oh, you weren't answering me that though.
No, because everybody else was saying that. I was waiting. Hopefully, you would say it louder. One last thing to look at here. Do we have a vertical shift?
No.
No. There's no vertical shift because your y coordinates have the same absolute value. You see that? Good.
I think it's easier doing it this way.
Yeah, I think so too. Because it takes a lot of the curves out of it.
Yeah.
It's forcing you to look at just one
bottom
shape.
is like-
If they give you too much little curves, no. That's too much curves. I don't know where it starts and where it ends.
Yeah. That's.
What was the A value here? 3. Thanks.
So
it's-
it's the amplitude 3 or negative 3?
3.
It's the absolute value.
It's the absolute value of it, yes. So it's, you just have to go vertical, so it's 3 cosine 1/2 x, and you're done, go to the next problem.
Are we gonna get one of these where they don't tell us the A's and X's?
You wouldn't be able to do it then, would you?
Okay, that's good. Wow.
What?
No,
Wow.
Do the next 2.
Is there not gonna be shift?
You get an 8 shift now.
Huh?
You get an 8 shift. And you're gonna get a tangent one, so Merry Christmas.
What?
So the rest of you guys don't have to worry about a horizontal shift
Oh.
or a tangent shift,
I thought you.
except for Caleb. And maybe Katie.
Oh, for the ACT.
Thanks for coming up for air.
I can see you doing something crazy on this test tomorrow, like that.
Oh, the other thing I just found out, the reason why I can't push the test off until Tuesday, I mean, first of all, there's really no reason to, but Monday and Tuesday, you guys are doing park stuff again.
Are they condensing it like?
Yeah,
this
it's only gonna take 2 days.
Yeah.
They're gonna do, like half the day on Monday, the first half Monday, last half Monday, first half Tuesday, last half Tuesday, last half. And half of all the juniors will go one part, the other half goes next, and they alternate the next day. So I don't know who's going to be. I think if they're doing it just pure alphabetically, because once you log in, it tells you what test to take. Not just juniors, but Alpha 2 or Humanities 3. So yeah, you're going to get half a day to do all of it, which means it'll take you guys 45 minutes or so. Come back into class. I do believe Monday and Tuesday, since we're going to be starting our next unit, which is probability and statistics, I think we might just start by counting cards.
Dude, I hate that. That was the worst
We should
part.
play
I
blackjack.
never played cards, so.
No, we'll probably play a little bit, because to start it out, I mean, the first few units, or first few things of probability and statistics, it's pure just counting principles. I might switch it to go into like dice rolling and things like that, because we can do those experiments with half a class and not have to worry about this. We will. We will.
How many cards there are? I don't play cards, I never knew that.
You'll have to learn. I want to talk about what to expect on the test for tomorrow. On 17, is there a vertical shift? Why is there not a vertical shift?
Because it's the equal distance between the.
Okay, because they have the same absolute value.
They have the same absolute value, okay? So now, that means that it's starting at a maximum value, starting at a maximum value of pi. Or, I'm sorry, the pi over, oops,
No.
it doesn't say that, duh. It says that pi is here, and 8 is here. And then it goes to 3 pi, and it goes to the opposite here. Which means that it had to do this, to go up, come down, to come back up. Because it means it had to start at 0. It had to start at 0 to go to its maximum, to get to its minimum, and so it means it has to go back to 0. So what graph is this? Sine. So you have a sine graph. What's your A value?
I really.
8.
Oh, 8.
I know that the distance between my max and min is half my period, so between pi and 3 pi is 2 pi. So the period is going to equal 4 pi. Set it equal to 2 pi over b. What's b again? And go on your merry way. Okay.
So it doesn't start like on the y-axis like that. We know it starts at 0 and goes up.
Yeah, unless there's a shift. Okay. Now the last one has a shift component to it. Do you agree?
Negative.
It's -2. And why is it -2?
Because -5 plus 1.
Very good. Is that easy? I know this has to have a shift to it because the 1 and the -5 don't have the same absolute value. The easiest way to figure out your k value is to take the average. Well, -5 plus 1 over 2, well, it's -2. So there's a vertical shift down of -2. We know that'll be put into the problem. I'm going to look at what this looks like. We have a maximum at 9 pi and 1, and a minimum at 3 pi here. So if I have a minimum prior to its maximum, the A value had to be negative. So we'll have an A value that's negative, which means in order to get there, we've already figured out that it had to be through here, which means it had to start there to get to the minimum, get to the maximum, to come back around. So is this a sine or a cosine?
Sine.
Sine graph. Nice. We knew that our A value, well, the vertical distance between here and here is how much?
3.
3. Wait, it's 3.
Right?
3.
Yeah.
Sorry. Counting is very difficult.
Wait, how did you move this in the other there?
Alright,
What's that, Izzy?
How did you find there?
Were you okay with figuring out that there was a vertical shift?
Yeah, I got the vertical.
Now, when you plotted it, since we have a minimum, then a maximum, and this minimum value isn't on the axis, that means the other point had to start there, which means it had to start as a sine graph. So it had to go from here to here,
Well, how did you know the other point was Yeah.
because it's not given to me. Because this was my max, and this is my min. If it was a cosine graph, it would start at the max or min on the y-axis. This doesn't start on the y-axis, even with the shift. So, the max or the min isn't on the axis. That means it went to the min, went up to the max. So if you start here, it means you're a sine graph, go to your minimum, go up to your maximum, and then back down.
I get that, but how did you know it was that negative?
To pick out your shift part,
like I know that.
what's 1 plus -5?
-4.
What's half of that?
The -2.
Correct. That's how we do that.
Okay, I got, yeah, I mean, you guys are saying.
What's the distance between 9 pi and 3 pi? Is double it, you get 12. So the period is 12 pi, set it equal to 2 pi over b. What?
1/6. Oh, 1/6.
1/6.
So we wind up with -3 sine 1/6 x. but I'm gonna bring in, I'll put a -2 plus that. I put the K out in front because it's a negative, it just looks cleaner.
Do you need the plus?
Yes.
Yeah, because we'll.
Oh, I see what you're saying. No.
Okay.
You could write it as -2 -3 sign, and that's fine. This is easy.
I'm sorry, I was still so confused how you got A.
A, okay.
Yeah.
You're okay now with why we have -2 as our shift down, correct?
Oh, no, I didn't.
Your K value occurs at the midpoint of your Y values, of your maximum and your min.
Yeah.
Now, how far is -2 from -5?
3.
Did you go up or down? That's why it's -3. Okay. All right. Quick, yes, ma'am.
Couldn't you just take like the distance between your maximum and your minimum and then divide it by 2 to get A?
Oh, if you do,
5 plus 1.
now, real fast, things to look at of what we've done. In 2.5, it was scatter plots. I hope you know what a scatter plot looks like. After that, it was 3.4, which was your linear programming. Yes, everything's going to be a calculator here. The linear programming one is those word problems. You have so many of this and so many of that. You want to make a profit, blah, blah, blah. Yes, I found 3 more of them that we have not done, and they're not terrible.
Wait,
So you get one, the other 2 classes get one as well.
that's 3.4. Wait, up.
3.4. After that, you had, what was it, 5.8?
Yeah.
5.8 was quadratic. How do you know if something was quadratic? Well, it had a bell curve. They were equidistant from a vertical asymptote. You were able to do a second degree finite differences, and all those would be the same. Remember the whole when we did the 666 thing?
Yeah. Illuminati.
That was like all 5.
666 is not.
It was 5.8 was quadratic. 6.7, same kind of idea, but it was polynomials. Also within the polynomials, I had you write out the equation of a polynomial given 3 intercepts and a point. Remember that? Where you had to write out the equation of y equals a blank, 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 blank.
Oh, yeah.
How'd I have you write it out? Okay? No, it's not. Pretty quick.
6.9.
Is that 6.9? Oh, whatever. 6.9.
Oh, yeah.
That's close. Then we did 8.7, which was the exponential. And the exponential ones you did with the graphs. Remember that was one you would look at your table, then you take the natural log to show that it was linear-ish?
Well, we only get one of those because those take a long.
Well, you'll never know. You'll see when you get it.
Wait, did you say it was test on Tuesday?
No, it's tomorrow. And then you also had to write out the equation, was y equals a b to the x. Remember we did a system with that also?
Awesome, you can skip it.
I'm not putting on there the one with the matrix where you had the 3x3 ones. I did not put that on there. That was the quadratic one.
Oh, yeah.
Okay, I'm not doing
The
that.
one that you're given 3 points to get the.
Yeah, I did not do that because
That's the one that I'm like.
it was fun. 8.8, that was your logistic.
No, those.
That was those weird graphs where you had the ordered pair of your maximum growth, the L natural log of A over R, and then it was C over 2.
Oh, yeah.
That was that one. Having to graph that with your asymptotes, pretty easy. The asymptote at C, the asymptote at 0. Everything was always increasing from left to right. Then we did this 14.5 was what we just finished up. And that was your sinusoids. It's kind of a fun word.
Sounds like science.
Why did he do though? Sinusoid?
Wait, what was it?
Sinus.
Scatter plots, it was it increasing or decreasing? It was kind of a waste of our money.
Wait, what? What was that?
Scatter plot.
Scatter plot.
Like we were given the schedule?
You had to make a scatter plot, yes.
I heard.
Yeah, which,
Well, we have to grab a really crappy scatter plot and say whether it's a positive or negative.
oh, I'll fix it. I never miss things.
happens to everyone.
Yes, no more than nothing. Yes, sir.
2.0 is literally just graphing
Right there.
your points.
So am I gonna waste my time and see that you know how to use a scatter plot?
All the questions are scatter plot.
Yeah. Can you identify a graph? If you have a graph,
Linear.
linear, very good.
Yeah, do another one.
Whoa, really?
Bar graph.
Quadratic. Cubic. Logistic.
Where's this exponential?
Sine.
Sinusoid.
No, that's
That's a
cos.
sine.
So is it quadrisoid?
What was the one you did before that? The adjusted your-
Logistic. The logistic are increasing.
Oh, yeah.
Exponential.
Oh yeah, I got that one too.
Exponential.
It's exponential because it's the rate of change is increasing each time.
Okay.
Are we doing anything with the graph for y equals
That's the exponential.
That's exponential. That's when you were given two ordered pairs, write the equation.
we don't have to do it.
Well, the graph of that one, if you're given a table and it looks exponential, remember to say that it is exponential. You would plot out
You don't
the,
have to do it.
you have to plot out the natural log of the y values versus the x to show that it's linear-ish.
I think she's asking that if you're given 2 points, you have to figure out if it's.
Oh,
You don't do that. You don't do that.
no, but if I give you an ordered pair, write the exponential model, you can do that. Right? That's that y equals ab to the x. If I give you xy, xy.
And then you can make two of them and then you have to.
That's pretty easy. Okay?
What was the one that, what section, because of these, that was like the 666. Like,
That was when you're doing your finite differences. Remember, if you're doing a finite difference in a table, I have a problem with
I'm gonna
that.
cry. I'm gonna cry.
So that was really like just graphing stuff that we did?
Yeah.
Just all.
And then just telling what your grade was?
So why did you erase the day I wrote in your? Why did you erase the day I wrote in your?
Like, I know, I can do the scales, so I can at least.
That was this stuff.
I know.
You get the windows up already.
When you're doing a finite difference, you were doing something like this, where you had one,
Smile and think you're kidding.
I
haven't been able to, like, yesterday, in a really short period of time on Sunday.
How would a problem like that be worded? That's in no way.
how would a problem like this be worded?
Yeah.
That's all. That's not good.
Write the equations of the model of the model of the data.
Subtracting all of this.
So then you'd have to look at it and go, okay.
Do you do the thing, the triangle down?
Negative
In this case, the quick thing to do is you can do an L1, L2, look at the graph, but you still got to show that it is. So you do your differences. So you have -2, 4,
So I got
16. Yeah, this would be 34,
So that it's,
52, 58.
then you can put in the equation, then you put L1 or whatever. Then you put it in the equation.
14 or 48.
Because if you go 3 degrees down.
It's 58. Oh, yeah, sorry, I'm sorry.
Well, you have to find the equation, you have to know what degree it is every from 14 to
Oh my gosh, bless you. 6 bless you.
So how many times do we subtract? Bless you. 1, 2, 3. So what model would I use? I use a cubic model in my equation.
I don't know.
6
In your equation.
What if it was 66?
Right. So in your calculator, you'd have L1, L2, and then you press cubic progression. There's your A, B, and C, and D. Right? The equation.
Make yours
Yup.
How many ways are
What if you do kids?
He does know.
My side job. Yes, I am. Yes, good. No. Yeah, it's fine.
Those the ones ones that are obviously, the ones that are obviously not.
Guys, question here.
For the ones that are obviously not, quadratic, cubic, or like square, do you still have to do that to show that it's not?
No, if you recognize right off the bat that it looks like it's increasing, like at a rapid rate, go ahead and go right to exponential.
Because like, you know that one is because it goes from a negative plus, it goes from a negative 4 to a negative 16.
Yeah.
But
Do you see the change?
if it's
in
obvious
direction?
that there's no change, then
Right.
you don't have to do it.
If you notice it might go right to your natural log, go for it. No problem. It's tough on a table because you start at a low value, it increases quickly, and then it changes tails off. So in the middle, there's a real fast rate of change, and then the change between the y values is.
I want something like that.
Again, to tell if a table set is exponential, when you go to your calculator and you look at your graph, if your graph looks like this, then you do the natural log of your y values to show that it's linear-ish. If it's linear-ish, then you know for certain that it's exponential.
On the test, are you going to just give us random tables or
Oh, I'll give you random tables. Because I'm telling you what it is, I'm telling you how to do it. It's a good question.
Wait.
Yes, sir.
So like find the equation that's calculated for the exponential one, you do it between the 1 and 2, right? Not the
Yes.
maximum.
Always go back to L1, L2, because your calculator will default to that. When you look at your L3 to see that it's linear-ish, you're just verifying in your head that, okay, I'm hitting the right button, and it's not like a quadratic that I don't see the other half.
Also, then we like if we would type in the L1, L2, and then do the natural log to get L3.
That was your separate.
Yes.
And then you had to go in and like change it to.
Change your window just to kind of look and see if it is linear-ish.
You only give the vertex and the
If it's not, then you have to come across it. I'm not giving you anything that's a power function, nor am I giving you like a straight logarithm. It's the logistic one that's linear.
Well, you're not doing a linear one. You're doing.
It's not gonna be bad.